So in the Quizlet class that you joined at the beginning of the year, I dropped in some terms for the unit, not terms, but some little flashcard things for the unit circle so that you can practice with those on your own. We're going to start today with the more unit circle practice. What we're going to do today, now there is no pressure, I'm not going to call anybody out, I'm not going to put anybody's stuff up on the screen. I want you to do this without looking at any materials that we've done so far. Like, don't look back at your notes, don't cheat, don't Google anything, because it's not going to benefit you any. I'm not going to grade it, I just want you to see what you can do right now. And if it's not all of it, that's okay. But I think you might surprise yourself as how much you actually can do. All right, so what I want you to do, I'm going to give you 10 minutes. I tried 5 last period and that wasn't enough. Sometimes the digital writing sources, and that's fine. So I'm going to give you 10 minutes, and I want you to fill in all the radian measures right around here that you can, and all of the ordered pairs. Just do the best you can, all right? No cheating, because it doesn't benefit you any. This is kind of for you, and we'll talk through it, okay? You've got 10 minutes. Shake a hand now. So if you're just watching the video, then you're going to need to pause the video, fill the circle out, and then come back and start it up again. Okay, so here is what we should have, and I saw quite a few circles that were, I know the handwriting is horrific because I did it with this crappy stylus at my desk quickly last period, but so this is what we should have. If you can't read something, let me know, but double check yourself, okay? Want you to remember a couple of things. Well, first of all, some people get really good at filling out the whole circle and are like, man, I got this down. But then when they're asked about specific different pieces of it, they struggle. So know that yes, this is important to do, but you're not always going to be filling out the entire thing. I think it does help you kind of place things and be able to picture it. But we also need to be able to just pull things out of the different places of it, and we're going to practice with that as well. So if you're not having to just fill out the whole thing, which may be a simpler process, depending on whatever order you did it in, remember that at the axis, if you think fractionally, it can really help you, because you're going to have to figure out what quadrants these are in without filling out the entire circle every time. So when I'm at pi, if I think about it as 6 pi sixths, I back up 1 to get to 5, or I go forward 1 to get to 7. Same thing for the fourths and the thirds and whatnot. And then if I'm at 12 pi sixths, I can back up 1 to get to 11 pi sixths, okay? Any questions about anything that's labeled on here? All right, so hopefully you see the reflections and the patterns and whatnot on here, and we're going to talk about a little bit more of what goes along with this. So let's go to the next page, which is your next blank circle. We're going to do something completely different on here. We're going to start by labeling our quadrants, which hopefully is a pretty easy thing for us to do. So quadrant 1, 2, 3, and 4. Then we know that our ordered pairs, what is the x value? Is it cosine or sine? Cosine. So that's cosine theta, sine theta. And then tangent theta is equal to, is it sine over cosine or cosine over sine? Is it y over x or x over y? It's y over x, so it is sine over cosine. All right, and then that reminds me, last period I had somebody ask, at the door when I was asking questions, they were struggling with the hand trick, like comprehending it. And I was trying to figure out why he was struggling, because I knew he knew the answer, but I think he was kind of overthinking it. And then when we talked about it, I realized that there was a misconception there that I hadn't even ever thought of, and that may be why some people kind of just don't get the hand trick. So remember when I said, when we have our hand, that the thumb is on the y-axis, and then your pinky's on the x-axis, right? But when you pull your finger back, your numbers are the ordered pairs, and your finger's like the comma. So this gives you your X, this gives you your Y. Well, he was getting it mixed up because I had just said that this was your Y-axis. That has nothing to do with the ordered pairs. Like basically there isn't a mathematical basis for the hand trick. It is literally a trick. Okay, sometimes we get to skip steps and do things that may make it look like it's magic, but it's not. There's math behind it. There is no math behind this. It just happens to work that way. Okay, so don't get caught up in the axis versus the ordered pair thing. It's just how it works. Okay, and if I need to help re-explain it to you individually, let me know, because I don't want you clouded with that, because it's something that could really, really help you. All right, so with all that said, so we're here. So we know from old knowledge that we've known forever, right, that in the first quadrant, our ordered pairs are positive, positive, right? Your X values are all positive, your Y values are all positive in the first quadrant. When we are in the second quadrant, is X positive or negative? Negative. So this is negative, positive for every ordered pair that exists in the second quadrant. Third quadrant is negative, negative. In fourth quadrant is positive, negative. Okay, so super old business, super easy, something we've known forever, but something that helps us, and this is why if we just know our first quadrant values, we can get the rest as far as the ordered pairs are concerned, because then we just know which ones are going to be positive and which ones are going to be negative if we have to change the sign. So let's think about all this in terms of sine and cosine. So in the first quadrant, so cosine is my X, sine is my Y, cosine and sine are both positive, and then tangent is sine over cosine, so that makes it positive also. So they are all positive in the first quadrant. Okay. When we move on to the second quadrant, cosine is negative because the X values are negative. So sine is positive, so sine theta would be positive. What would tangent be, positive or negative? Negative, because we'd put the positive over the negative, makes it negative. So sine is the only thing that's positive in the second quadrant. In the third quadrant, cosine is negative, sine is negative. What would tangent be? Positive, because we'd put negative over negative. So tangent theta is positive. Then in the fourth quadrant, cosine is positive. Clearly sine is negative. What about tangent? Negative, because we'd put negative over positive. All right. So if I ask you, what is the cosine of 5 pi sixths? So the first thing you want to think about is, where is 5 pi sixths? It's going to be, since this would be 6 pi 6, I'm going to be in the second quadrant. And I'm asking you for the cosine. Well, in the second quadrant, the only thing positive is sine, which means my value is negative. Now I can forget the 5 part, because my reference angle is pi 6. So pi 6, my cosine is the square root of 3 over 2, but since it's in the second quadrant, it's negative. And that's how you know what your value is. Okay? We all good with that? Now, to remember which quadrants without having to think through it, there's a little acronym thing here that it is all students take calculus. So all students take calculus. That's what this is right here. All students take calculus. So when you're trying to just have something there to refer to, or what you can think about in your mind, is if here are your little quadrants, all students take calculus, and that tells you which functions are positive in those quadrants. They're all positive in the first quadrant. In the second quadrant, it's sine. In the third quadrant, it's tangent. In the fourth quadrant, it's cosine. Okay? What questions do we have? Alrighty. So then, the next two circles are blank. They're just for you to practice on your own whenever you want to, so you don't have to erase other things. You may want to practice filling the whole thing out, or just the angles, or just, whatever you have, but there's just one that's kind of easy for you to do that's drawn nicely. All right? All right, so you can hit terminate on that. You can always come back to it. And then let's move on to the other part, which is unit circle reference. So if you notice on this one, I filled in part of the ordered pairs for you. Not the quadrantal angles, but all of the other ordered pairs that aren't quadrantals, I put the denominators in because I wanted you to see they're all 2. Okay? If it's not a quadrantal angle, and I ask you for the cosine or the sine, it is something over 2. Could be a positive something, could be a negative something, but it's all over 2. You're not going to have a different denominator if it is sine or cosine. Tangent and the other ones are a different story, but if it's sine or cosine. All right, so let's fill this one in. I know here at 0, this is 1, 0. Actually, let's do our angles first. I guess that would probably be better. So we're going to do 0 and 2 pi, pi 6, pi fourths, pi thirds, pi halves. You go ahead and finish up the angles in radians. Okay, so then let's start with the ordered pairs. Let's use the hand trick. For pi sixths, my x value, square root of 3 over 2. My y value, 1/2. For pi fourths, they're the same. So I get square root of 2 over square root of 2 and square root of 2 over square root of 2. For pi thirds, my hand trick, I get 1/2 and square root of 3 over 2. If you can get that much done with your ordered pairs, the rest are reflections, and maybe you change the sign. Okay, so you should hopefully be able to fill out the rest of the circle without me. I'm going to do it without talking through it. Try to do it without just copying mine down. Are there any questions about any of the values or anything on the circle here? Right. It's going to get better and better. So let me ask you this. If you think about everything we've done this semester, the majority of the time we do a lesson, we learn something. The next day we move on to an extension of that or something, but it's pretty much something different almost every single day. We've been on this for days and we're not finished. So do you think it's important? Yes, that's one reason why I'm spending so much time on it, because I want to help you get it down and not just say, hey, know this, and then we move on, okay? All right, so let's scroll to the bottom of this. Let's fill in some of the stuff that we already have. We're kind of saying some of the same things, but not exactly. So when we talk about the quadrants for the positive trig values, we know that in quadrant 1, they're all positive, everything. But we only talked about sine, cosine, and tangent. We didn't talk about their reciprocals, secant, cosecant, and cotangent, all right? So in quadrant 2, right, so if we think about let's go ahead and rewrite this. All students take calculus. Right, so we can have this. All students take calculus. So from that little acronym that we could draw in our little quadrants, quadrant 2, what does this S mean? Sine is positive, right? But not just sine, so we're going to write sine theta, and its reciprocal. What is the reciprocal of sine? Do we remember? Cosecant, yes, cosecant. So that means that sine and cosecant are both going to be positive because it's just a reciprocal that doesn't change a sign. And once I feel like we've really got sine, cosine, and tangent done, we haven't even focused on tangent much yet, then we'll start focusing on the other ones. But we got to get these solid first. Okay, quadrant 3 of sine, cosine, and tangent, which one's positive? What does this mean? Tangent. So tangent theta, and what's its reciprocal? Cotangent. Yeah, that's the easy one. Then in quadrant 4, this C means that it is cosine theta, and its reciprocal, which is secant. Yeah. Remember, there's only one co in each pair. Excuse me. All right. So now we have the trig values. We're just going to talk about them as far as coordinates, the x and y. So sine theta we know is y. Cosine theta we know is x. Tangent we know is sine over cosine, but as far as y and x, that would be y over x. Cosecant being the reciprocal of sine, this is 1 over y. Secant would be 1 over x. Then cotangent would be x over y. Okay. Any questions at all? All right. So, your assignment today is not in Delta Math. There are detailed instructions in Schoology, so I need all of you, once you've hit turned in and you've finished this, to go ahead and go into Schoology and open the assignment so we can go through it.